Hello Dell, we are GHug Solution and we are happy to have you again. This is our table for today. First, let us tell you about our main problem. The problem faces new mothers, our target users, and our motivation. Then telling you what is GHug, its feature, and the current solutions. After that, you will see our SWOT analysis, then the methodologies. Finally, presenting our deliverables and future plans. We decided to focus on babies, as we found that there are 4.5 babies are born every second around the world, according to the UN. So, let's see what happens to this huge population. Those are some statistics about newborns. Every year, nearly 41% of all under 5 child deaths are among newborn. 2/3 of newborn deaths can be prevented if their health measures are provided at birth and during the first week. 1 in 2 suffer from deficiencies in essential vitamins and nutrition, such as vitamin A and iron. A woman dies every 2 minutes in childbirth or as a result of complications arising from pregnancy. This means that the responsibility of caring about her baby goes to father or someone else. Now let's see the problem faces the newborn's mothers. These days we strongly notice that motherhood is not easy at all. She suffers from many unknown matters, especially when dealing with her first child, and some questions are rising in her mind, such as, why is the baby crying? Is he in a good health or not? Is his temperature high or normal? Does he sleep well enough to grow up healthily and breathing well during sleeping? Will we be able to remember all of the dates of medicine and vaccination? We found that in every 10 women, there is a woman who will experience postpartum depression after giving birth, and now you know the reasons. So, how can she deal with all this information and at the same time go to work, take care of her baby, and balance a lot of things? The answer will be GHug, but before showing the details, let me tell you about our targeted users. We decided to make our solution focus on new mothers who are well educated, having a mid-income, aged from 22 to 37, and interested in health lifestyle. There is one thing left before GHug solution. We would like to share with you our motivations. As you can see, the mother and the child healthcare market will reach 1,795 billion by 2030. We are seeking to release children with health lifestyle. And we found that the current solution only covers part of the problem. We also want to avoid sudden infant death syndrome, as about 3,500 babies in the United States die suddenly and unexpectedly every year.
After seeing the problem and motivation, now I can tell you what is GHug. GHug is a mobile-based application that requires smart plans to help parents in taking care of their babies and understand them better. And by the way, GHug means growing healthy giggling with us and also means great hug. Our project provides smart band, mobile application, and website. The smart band is a wearable device that measures the vital signs of the baby. So it contains sensors like heart rate, oximeter, and temperature. In addition to body composition and mild that notify mom if baby is crying or anything happening around it. The second part is a mobile application, which is used in displaying the data that come from the band in addition to other features like cry translator to understand the baby's cry, monitoring sleep quality, month-to-month guide for tracking the baby growth, and reminder for medicine, vaccination, and so on. The last part is a website for marketing and selling our band. Now let's take a look at our system architecture. It describes how the system works in a simple way. And here is the technologies we used in the project. We used Adobe XD and UI/UX design, Python with Django in backend development, Flutter with Dart in application development, Tailwind CSS with HTML, JavaScript in front-end, TensorFlow for machine learning, and Keras for deep learning, and finally Arduino IDE with hardware. Like we know, we have hardware and software, so we have two comparisons. First one is with competitors that provide hardware. They have different forms of hardware, like diaper, button, tuck, and band. Also, they have different features, like we see here. Some have heart rate, temperature, and oxygen level, some have only oxygen level, and so on. Second one is with competitors that provide only software. And as we can see here, they provide some of our features, not all. Finally, with these all competitors, we made our SWOT analysis to understand our strengths, weaknesses, opportunities, and threats. Let's go through them quickly. First, our main strength point is that we are providing an accurate cry detection and description feature, besides the smart band. Secondly, weaknesses come from lack of training data and some branding issues. Thirdly, our opportunities is that we added more sleep features and entering the metaverse. Finally, our threats come from the risk due to mother concern about technology with baby and rapid technology changes.
And now we will move to talk about the methodologies of the features. At first, we will see the two features, sound classification and the cry translator. And the feature here depends on the presence of two parts. We can use each of them separately. If the mother wants to leave the baby, she can through the mic detect the sounds around the baby and know what these sounds are. And if the baby starts crying, she can use the cry translator module. The input we have is the sound of a child crying, and sound data is a more complex format. It's a mixture of frequencies and waves with different intensities. As shown here, we can express sound by its frequency and its time. For datasets, we used environmental sound classification dataset for sounds in the environment. It's all about 10 classes for each voice. And in order to analyze the reason for crying, we merged two datasets, infant's cry sound and neonate cry, which are 5 classes. Now let's have a quick look about preprocessing. As shown here, the steps of the model which we follow. The first thing, we started reading the records and converted them to an array so that we could enter them to any model through the Librosa library because it can read the audio in the one-dimensional num-by-time domain. The second thing was an experiment for the Fourier transform, but we found that it's closer to the original data. Then we tried the spectrum moments such as centroid of waves, spectrum, and bandwidth. Also, we tried the Mel spectrogram, and it made extraction from the frequency and put it the matrix of 2 dimensions. We made sure that the signal in level is different from the frequency and time. We were dealing with the point that not all records have the same extension or the same length by resampling. Finally, in feature extraction step, here we see because the voice is a human feature changes quickly, we found that we depend on many frames. So, through the MFCC, we were able to calculate the strength of each frame. So it isolates the frequency faster and can also deal with the noise. It's calculated from this equation. Finally, the deep learning modeling, architecture, and the results.
Let's talk about the building of multi-level model. We choose CNN because it chooses the most important characteristic feature automatically without human intervention. Unlike other solutions or models that you need to enter them and impose an arithmetic step which increase in processing. In addition to that, the experiment have proven that the CNN reduces error rate from 6 to 10%. As for the number of hidden layers, they are 4 convolution 1D mixed with 4 max pooling, followed by 2 fully connected layer or dense layer. We divided the data into a smaller group, which was 32 batch size. We set the number of times to train the neural network to 100 epoch, and for scaling over the 10, we assigned dropout by 310. Our data had been split 80 in the train 20 test. Moving to the final step from building the model, we used Adam as optimizer. By using the accuracy metric and the loss cross entropy, we were able to determine the performance of the model. At the end of the multi-level model, in the first model, the result will be from Dell label, which achieved an accuracy of 82%. That seems good for voices, including the cry label, which if it was the output of the prediction, then it will be the turn of the second model, which follows the same steps that we mentioned in building and processing. And the result will be 5 classes, with the probability that this will be the actual cause of crying and achieve accuracy 81%. Now let's review the result of models. First, we are going to listen to baby cry and then vehicle sound, which will be very annoying. Sorry for that. Now we are going to see why that baby cried. It seems he is hungry. Sleep quality. The benefit is that the growth hormone is secreted during the sleep of the child, and therefore its knowledge helps the mother to monitor the health of her baby. When children sleep every night, their body goes through the stages of sleep that ends with an average of 90 minutes. In each cycle, there is an alternation between the stages of light and sleep deep and the time when the mind is less active. We use the Fitbit dataset, which is fitness product that helps you to stay motivated and improve your health by tracking your activity, exercise, and so on. We use linear regression and relied on the number of minutes that child sleep, the number of times they woke up, and the time they spent in bed to predict the efficiency of sleep. Output will be efficiency sleep. Based on the Fitbit range, we can determine the score ranges, which are fair, good, and bad. Also, sleep stages frame light and deep.
Now, it's the time to talk about our prototypes. Let's start with the mobile application. We use Flutter framework as it helped us to save time by developing two mobile apps, Android and iOS, at the same time. First, you will see an onboarding screen which shows our application functionality. Then you will go to Login and Register screen. For registration, user enter their information, then the baby information data. After finishing registration process, you will go to the home screen. It contains a reminder center for feeding, medicine, and so on. It also has some types for moms that provide them with good advice and article to raise their babies. Then you can go to the crying translator screen. It has a crying history and the crying recorder to record a new cry and analyze it to know the reason for the baby crying. There is also a measurement screen. It displays the data come from the device, such as heart rate, oxygen level, temperature, in addition to sleep quality. Last but not least, body tracking screen. It keeps tracking the physical and behavior changes of the baby's body month by month for the first year. Finally, it's the profile screen. It's not only displays the baby's data, but also have scene calendar. The last thing is an album to save the baby's special memory. And those are the app settings. In addition to our mobile app, we have our own website. We use it for marketing and present our service to provide customers with the information they need before buying our device. There is also a testimonial section of user feedback. The last thing in the landing page is the contact form to keep you in touch with us. For purchasing our device, you can easily buy with Visa, MasterCard, or even PayPal.
Now, we will talk in hardware section. In this diagram shows our hardware component and how they are connected together. In this demo, as we can see, the reading of the sensor on the Arduino board. And because the bands are connected to the application, we can see the reading on the application too. This is the reading on the Arduino board, and then we can see the reading on the mobile application. We developed our sensor to look like a band, so this is our first step. And we didn't stop here. We tried to develop it more to look like a real band, but in reality, it's not the final look. We use it in the testing process, but we will make it more realistic. The final thing in our deliverables is our perceptions in the metaverse. It's a 3D room simulating a baby's room, and the mother can enter it and make sure her baby is in a good health, as his vital signs will be displayed all the time. Now, it's time to share our future plan with you. We wanted to enhance the accuracy of the models and make a sleep prediction to tell you sleeping and waking up times for your baby. We decided to put the in-body measurement in our future plan and started to enter the metaverse, in addition to be the first project who enters the baby into the virtual world. The last thing for now, we wanted to make a feed prediction for baby to tell mother the next time they have to feed their baby. And finally, automating our wearable device. Now, we're to the end of the page. So, thank you for listening.